Hi everyone, today is January 7th. We are looking at the medium integral on DailyIntegral.com. So please take a minute and try to solve it for yourself. And now we shall start this. So here we have an arctan. So what we can do is we can try substituting x squared minus 1 over x. The reason we're gonna leave this root 3, right, and just factor it out like there. So that's gonna look like arctan of 1 over square root 3 x squared minus 1 over x. So we're just gonna keep it like this, and then we can substitute in x squared minus 1 over x. So u is equal to x squared minus 1, u is equal to x squared minus 1 over x. This is x minus 1 over x. So now we have du, that's going to be equal to 1 plus 1 over x squared. Okay, let's switch the bounds on the integral. We plug in 1, we have 1 minus 1 over 1, that is 0. Then we'll have root 3 minus 1 over, we'll have root 3, let's plug in our second bound, so we'll have root 3 minus 1 over root 3. This is the same as 2 over root 3. Okay, let's plug this in here. So 2 over square roots of 3. Okay, and now we can start putting stuff in. So first, the x squared. Okay, we're gonna factor out x squared on both sides, so we'll divide by x squared, and this will come 1 plus 1 over x squared. All of this is over x squared plus 1 plus 1 over x squared I squared arctan of u over square root of 3 du over 1 plus 1 over x squared. So by doing this, by taking out the x squareds over here, dividing by x squared on the top and the bottom, we were able to get 1 plus 1 over x squared. So we can now just cancel these out. So we are now 0 over 2 square root 0 to 2 over square root of 3. We are left with 1 over x squared plus 1 over x squared. There should be a plus here. Pi squared plus arctan of u over square root of 3 du. Okay. Now, we need to somehow plug in u for x squared plus 1 over x squared. So we need to solve for this in terms of u. So we can do that by squaring u. So we'll get u squared is equal to x squared minus 2 plus 1 over x squared. U was x minus 1 over x, and here we have x squared minus 2 plus 1 over x squared. We want u squared plus 1 over x squared, so we can just add 3 on both sides, and we have x squared plus 1 over x squared. So now we have the integral from 0 to 2 over square root 3, 1 over u squared plus 3 times pi squared plus arctan of u over square root 3 du. Okay, now notice here that we have a u squared plus 3, 1 over u squared plus 3, and arctan of u over square root of 3. So this is basically, it's almost the derivative of arctan of u over square root of 3. So that's going to be something good that we should substitute. So let's say t is equal to arctan of u over square root of 3. dt is going to be 1 over 1 plus u squared over 3 times 1 over square root of 3. And we're going to multiply this by square root of 3 over square root of 3, just to make this just to rationalize this on the bottom, and we'll get square root of 3 over u squared plus 3. Great. So now this substitution would work great. However, there is one thing we could do instead. We can, instead of doing this, so this is a great idea, we can modify this a little bit. Oops. 1 over square roots and instead plug in t plus pi squared. Since constants are going to become 0, this does not make any difference. Great. So now we have the integral, not from 0 now. We have arctan of u over square root of 3. Arctan of 0 is 0 plus pi squared, so we start at pi squared. 2 arctan of 2 over 3. Arctan of 2 over root 3. So root 3 times root 3 is 2 over 3 plus pi squared. Okay, 1 over t, right? Now we're gonna need, we can cross out the u squared plus 3, and we'll be left with 1 over square root of 3 at the beginning dt. 1 over t is just the natural log of t, the absolute value of t, more specifically. However, that will not make a very big difference. Now we can plug in our bounds. So natural log of arctan of 2 over 3 plus pi squared minus ln of pi squared. Here is our answer. Very nice. So this is going to be approximately positive 0.033.